Hello friends, welcome back to the LFX online tutorial. My name is Master Jaffet and today we are going to be treating polynomials and factorizations of polynomials. What's a polynomial? Okay, a polynomial is a mathematical equation when we have x of degree n, that is x carrying a power of n. Most times it is written in this form. Let's say we have y and a constant a having x. It is written in this form. Let's say we have y and a coefficient a, and this x representing a constant with the power of what? N as the highest power. So n having the highest power, n begins to reduce subsequently. Let's say we have a, then another coefficient b. This coefficient could be any number, 1 2 3 4 5, any integer at all. So we have another one b, and the power begins to reduce by what? 1. And we have another one c, the power reduced again by 1. So 1 minus this is what? N minus 2. Subsequently till we have what? A constant, a coefficient, till we have a coefficient having x, and lastly we have a what? A constant k, a number without what? This x. We're going to talk about the types of polynomials, and we are going to discuss about the types of polynomials by their degree. The n is a representation of the degree, is how we know the degree. That n you see there, when I say x raised power n, is the degree. So meaning x raised power what? If you say x raised power 2, the degree of that equation is what? 2. X raised power 3, the degree of that equation is what? 3. So basically, for the sake of this class, we are going to stop at degree of what? N equals to 3. And so when n equals to 3, that equation is called a cubic polynomial. So we have let's say an example like the one in your notes. This is an example of a cubic polynomial. Why? Because the power here is raised to power what? 3. And if you look at just following the rule of polynomial, like I said, subsequently the power begins to what? Reduce. You can see reduced by 1, then this reduced by 1, then to a point where it reduced by 0. It gets to 0 because x raised to power 0 gives us 1, and 1 times 3 here is 3. So this is what we have here, and we have a constant 3. All these here are coefficients. The quadratic polynomial. The quadratic polynomial, for example, we have this equation that says y equals to 3x raised to power 2 plus x plus 4. This is a quadratic equation because it has a power of what? 2. A max highest power of 2, and subsequently reduced following the law of polynomials. And lastly, the type of polynomial we are going to talk about today is linear polynomial. So we have, of course, it's going to have a power of what? 1. For example, y equals 4x plus 3. Like I earlier said, we are going to be treating polynomials and factorization. Now, what is factorization? Factorization means breaking down a polynomial into simpler expressions, and those simpler expressions are called factors. So we'll break down a long and complex polynomial into a smaller fraction factors that if we multiply those factors together, it gives back that polynomial we broke down. You understand? They are smaller units of, for instance, let's say we have number like 8, um, 24, and 40. Okay, so we could break this 8 into smaller factors like what? Let's say 2 times 4. These are factors. What is this? We have 24, so we could break this into smaller factors like 12 times 2, right? And we could also break this into smaller factor like 8 times 5. This 8 is a factor of 40, 5 is a factor of 40, and all these are factors, right? Now, there is a way to work factorization. Just two major rules. Firstly, you find the HCF, the highest common factor, and so meaning a polynomial have several terms. These are terms. So when they are a term, another term, another term, we find the highest common factor among all the terms. That is a factor that can go in all. If I ask you what is a factor that can go in this, and this, you easily tell me 2, right? Yes, because 8 in 2 gives you 4. 24 in 2, 2 in 24 gives us 12. 2 in 40 gives us 20, right? But this time around, 2 is the smallest number possible that could go in this. So we are talking about the highest common factor. That is a factor that they have in common, but that is the highest of their common factor. So what do? If you can still remember how to solve the highest common factor, we may not be doing that here. But this, let's say we have 8 times 5, and this gives us 8 times 3, and this gives us 1 times 8. 8 is the highest possible number that can go in all this, right? And 8 is the highest common factor here. So, and now we are left with numbers that nothing can go in them again, 1, 3, 5, right? So in the same way, let's solve a polynomial question. Let's take an example. So if you're asked to factorize this, a raised to power 3 minus 3a squared plus a. So how do we do that? Firstly, like I said, we find the highest common factor in all these terms. This we have about 3 terms here. So the highest common factor in this is a. A can go in this, a can go here, a can go here successfully, right? So we bring that out. A. So let's divide it. A in a raised power 3. Hope you know a raised power 3 means a times a times a. So what I'm saying, a raised power 3 divided by a. So a raised power 3 divided by a gives us a times a times a divided by a, right? So one of these cancels and we have a square, right? So a raised power a divided by a raised power 3 divided by a gives us a square minus, so 3a square in a will give us what? 3a plus, and a in a will give us 1. You get that is a divided by a gives us 1. A 3a square divided by a gives us what? 3a. Okay, if you're asked to factorize 3a x squared minus 9a square x, so factorize, remember the first thing we do is to find the highest common factor, a factor that can go in these two terms and is the highest of them all. So when we look at this, we see that 3 can go. It's a factor here. We bring it out. 3. Another highest common factor that can go here is what? A. And what else? Another highest common factor that can go here is x. So a can go, not a square, because we don't have a square in both. So not x square, because we don't have x square in both. So x will go here once, and if we had s square here, we would have put s square. You understand? If we had s square here, we would have put x square. I didn't mean we had a square in both here, we would have put a square. I didn't mean we had 9 here, we would have put 9 here. So the highest common factor that could go in this term is just 3a and what? X. And let's divide it. 3ax divided by 3ax square. So what do we have? 3ax square, that is x times x, divided by 3ax. What happened? 3 cancels 3, a cancels a, and x cancels 1x. We're left with only 1x now. So we have what? X here, minus the sign remains 9a. That's a square is what? A times x over what? 3ax. That's what we are using to divide. And we have x cancel x, a cancel a, 3 here 1, and 3 in 9 give us what? 3. So practically what we are left with is 3 and what? A for this operation, and we have 3a. So we've just completely factorized 3ax square minus 9a square x. Let's take the last example for today. Now, there are times we are faced with challenges like this, where we have so many confusing terms mixed up: a, c, a, d, a, b, and so on. The first thing you do is to group the terms. So grouping the terms means we encapsulate them in a bracket. So we have AC and AD in a bracket, BC and BD in a bracket. So this time around they are in group of 2. Now we find the common factor, the highest common factor in each group. So the highest common factor here is A. You are right. So we have A, and A in AC gives us C left. A in AD gives us what? You are correct, D. So we have plus. Here, this time around, we have what is common here? B. So B is common. So we have B. B in BC gives us C, plus B in BD gives us what? D. Right? So the if you look at there's something there's something making sense here now. We have C plus D and C plus D here. The C plus D and C plus D here is the common factor in this arrangement. So since it's a common factor, we bring one, we choose one of it, right? That's what we do. So we have another group now, group of 2 terms: B, C plus D, A, C plus D. So we choose one common factor, which the highest common factor here again now is what? C plus D, right? Just way we do this, we pick the highest common factor, which is what? A, right, out. Now the highest common factor here now is what? C plus D, and we are left with C plus D divided by this. See what we mean? If you have A, C plus D divided by C plus D, now what we left is C plus D to cancel C plus D, right? So C plus D divided by this gives us what? A, and C plus D divided by B, C plus D give us what? Plus B. So, and if you see, this can be multiplied with A plus B, and that's why it should be encapsulated in brackets. So our answer for factorizing A plus C, AC, AD, and BC, BD is what? Plus C plus D, A plus B, written in this manner. So you have to watch the video over and over again for you to get it. This is a very simple way of factorizing. There are more and more to come. So take this one as your takeaway. Please drop your answer in the comment section after doing that. Factorize x squared plus xy plus x minus y. Drop your answer in the comment section. Thank you.